Turn it back on. Okay, so do dydx equals 1 over x. Here we go. Where did I leave it? Here we go. Okay, now I remember where I left off. And I'll leave that. Now I know where I messed up. Okay, that equals x. Sorry about that. Forgot to differentiate both sides of this one. Something threw me off. Okay, now we have our e to the y dy dx equals 1. Okay, divide both sides by e to the y, you get dy dx equals 1 over e to the y, which gives us 1 over e to the natural log of x, which is just 1 over x. My steps got mixed up somewhere. All right, so let's say, for example, we wanted to find f prime of x for f of x equals natural log of 3x to the third plus 4x squared plus x plus 4. Okay, so we want to remember the derivative natural log of g of x is g prime of x over g of x. Okay, so if we let our g of x equal 3x to the third plus 4x squared plus x plus 4, which means our g prime of x, if we bring down the 3 here, that gives us 9x squared, plus we bring down our 2, 8x, plus 1. Okay, so that means our derivative, I guess we could just say f prime of x. So f prime of x is just going to equal, of course, our g prime of x over g of x, which is 9x squared plus 8x plus 1 over 3x to the third plus 4x squared plus x plus 4. All right, and that's your answer.
No quotient rule or anything after there to follow?
Nope.
That's it?
Yep, that's it.
What's the catch?
For this part, there's no catch. It actually is a catch when you have to do it, use all of these steps later, but for these, it's just remembering the formulas. I know I get nervous. I'm like, okay, that's too easy. Okay. All right, so do a quick reminder. Of your basic properties of logarithm. So let's say if you have the natural log of some m times n, then that's going to equal the natural log of m plus the natural log of n. That's the product rule of logarithms. Now if you have the natural log of m divided by n, that's going to equal the natural log of m minus the natural log of n, which is the quotient rule of logarithms. And if you have the natural log of some m raised to the power of p, you just bring that exponent down to the front, and that's the power rule of logarithms. Okay. You probably saw them in Math 1000 and probably again in 1415, I believe. But just in case you forgot them, there they are. All right. Okay, so let's say, for example, you wanted to find the derivative of f of x equals the natural log of 3x plus 2 to the 5th power. Okay. Now, using the power rule of logarithms, that 5 just comes down to the front. So that means that f of x is equal to 5 times the natural log of 3x plus 2. Okay. And now we can just find our f prime of x. Okay. Where if g of x is equal to 3x plus 2, which means your g prime of x is equal to 3 once you differentiate that one. Okay, so we know that our f prime of x of that natural log function is going to equal, I guess you could say, 5 times g prime of x over g of x, since we brought that 5 out to the front. Okay, so that's going to equal 5 times 3 over 3x plus 2, which gives us 15 over 3x plus 2. All right, any questions on that one? Okay. Finally decent. Okay, so let's say if we have another example. Find the derivative of f of x equals the natural log of x squared over 2x plus 1. Okay. So if you had just x squared over 2x plus 1, you'd be thinking quotient rule. But with natural logs, you won't have to use the quotient rule. Because remember, the natural log of m over n is equal to the natural log of m minus the natural log of n. So bring that up some. Okay, So this f of x is actually equal to the natural log of x squared minus the natural log of 2x plus 1. Okay. We could actually apply the power rule here. So that 2 can come down to the front. So that means our f of x is equal to the 2 times the natural log of x minus the natural log of 2x plus 1. Okay. And now we just differentiate both of those terms. Okay. So our f prime of x is equal to 2 times the derivative of natural log of x minus the derivative of natural log of 2x plus 1. Okay. Now for this one, we know that's just 1 over x. But for this one, you have g of x equals 2x plus 1, which means your g prime of x is equal to 2. Okay. So that means our f prime of x is equal to 2 times 1 over x minus, remember that's just g prime over g, which is 2 over 2x plus 2x minus that plus 1? Yeah, plus 1. Or if you wanted to rewrite it, you can make it 2 over x, 2 over 2x plus 1. All right, and that's your final answer. Straighten that 2 up a little bit. All right, any questions on this one?
You wouldn't try to simplify by getting them over the same base?
You can if you want to. You don't really have to. All right. Okay, so now we're going to find the derivative of any number other than e to the power of x. So derivative of general exponential functions. Okay, so what if we let y equals, instead of e to the x, let's say it's just some a to the power of x, where a is some positive number. The derivative of any number to the power of x is just a to the x times natural log of whatever that base happens to be. Okay, and the derivative of a, let's say to some power of g of x, is equal to a, clean that up a little, a to the power of g of x times natural log of a times g prime of x. Okay, so for most of these, the difference between the basic derivative and the g of x derivative is you're multiplying it by the derivative of your g of x. All right, so let's say, for example, if we have, find the derivative of y equals 2 to the x squared power. Okay, so we know the derivative of 2 to the x squared. We know that g of x equals x squared. So our g prime of x equals 2x. Okay. So that's, oh, and your a is equal to 2. Okay. So we know a to the g prime of x, which is 2 to the x squared, times the natural log of 2 times your g prime of x, which is 2x. You could try to simplify that to make that 2x squared plus 1 times x times natural log of 2, but you don't have to. That would actually be good enough. All right, any questions on that one? Okay. Okay. Okay, so we have the derivative of a log function of any base. Okay, so let's say if we have some base of a greater than 0 and x is positive. Then, well, for 1, the derivative of log base a of x is equal to 1 over x times natural log of a. And the derivative of log base a of some g of x is equal to 1 over g of x times natural log of a times g prime of x. Or you can make it g prime of x over g of x natural log of a. Okay, so quick proof of the first one. Okay, so we know that log base a of x is equal to natural log of x over natural log of a by the change of base formula. Okay, so that means the derivative of log base a of x is equal to the derivative of natural log of x over natural log of a. Natural log of a is just a constant, so we can factor that out. Times the derivative of natural log of x. Okay. So we've already figured out that's 1 over x. So that's 1 over natural log of a times 1 over x, which is just 1 over x natural log of a. Oops, clean that up a little. All right, so for example, if he wants to write in, I'll leave that up for a few more seconds. All right. Okay, so let's say, for example, if we wanted to find h prime of x when h of x is equal to log base 4 of 5x to the third plus 2. Okay, so the first thing we know is our g of x, which is what's in there. So g of x equals 5x to the third plus 2. And our g prime of x is equal to 15x squared. Okay, so if we remember our formula, log base a of g of x equals, might as well say g prime of x over g of x times natural log of a. We know here that a is equal to 4. And we have our g of x and our x already there, so we might as well just line it up with the rest of them. Okay, so that means your h prime of x is equal to g prime of x, which is 15x squared, over g of x, which is 5x to the third plus 2, times natural log of a. So natural log of 4. And that's your final answer. So most of these natural logs all revolve around g of x. So once you find your g of x, your g prime of x, and your a, if they have an a, then you're pretty much set. All right, any questions on this one? Yes.
So would log base 10 just be log?
Yep, if you saw just log, so that would be log base 10, which, yep, it would just be log. So if you saw just log, then you know it has a base of 10.
Alright, so then would you substitute 10 in for a then?
Yep,
Or
then
would you just do it without it? 'Cause I think everything's based off that. 10.
Yep, so you would replace the, if you had log base 10, then a would just become
Yeah, so
10.
if that was log 10 of that, it would
Mhm.
be the
Yep,
natural log
so-
of 10 would be the bottom. So it would be g of x times ln of 10.
Yep, times ln of 10.
Alright.
So if you have a log of 5, I mean a base of 5 would be log of, natural log of 5.
Okay.
So whatever that changes to. All right. So all of those actually all led up. Oh, you want to do writing? To logarithmic differentiation. Okay. Where let's say if you have some, let's say we just write guidelines. Okay, let's say if you have some y equals some function of x raised to the power of some function of x. Okay. First thing you want to do is apply natural log to both sides. Okay. So your second step, you're going to use the properties of logarithms to expand it as much as possible. And in most cases, that's mainly using the power rule. The power rule for logarithms. I have to make sure I say that, so it's not the same as the power rule for differentiating. Okay. And then you want to differentiate both sides. Okay. Now, if you did it right, the left side should be 1 over y times dy dx. Then you multiply both sides by y and replace y with your f of x to the power of g of x that you started with. All right. So let's say, for example, we wanted to find h prime of x for y equals x to the power of x. Okay. So the first thing you want to do is apply natural log to both sides. Okay. That gives you natural log of y equals the natural log of x to the power of x. Okay. And remember that power rule for logs. That x goes down to the front. So you have natural log of y equals x, natural log of x. Okay. Okay. I'm going to be your third step is you're going to differentiate both sides. Okay. So remember, if you differentiate natural log of y and the derivative of x, natural log of x. Okay. Now for the right side, you're going to have to use the product rule for derivatives. Okay. So if we differentiate the left side, remember natural log of x is 1 over x, so natural log of y would be 1 over y times y prime, or dy dx, equals, you have the first times derivative of the second. Oh, hold on once. No, I forgot something. Oh, right back.